have your attention, please? I request all seated in the audience, especially the students, to please maintain discipline during the oration program. It is requested that all of you please keep your phones either switched off or on non-vibrating silent mode only. And the faculty members who are there in the auditorium, please ensure discipline amongst the students. Students, you are not supposed to leave the auditorium or move around once the program starts. So please take your seats and maintain discipline. Students, please settle down. May I have your attention, please? The dignitaries, along with our chief guest, are just about to arrive in the auditorium. I once again request all seated in the auditorium to keep their phones on silent, non-vibrating mode or either switched off. And please, students, maintain discipline during the entire oration program. Thank you.
but I need to connect it here.
Yes, sir. After video play.
Oh, okay.
There is a
But do
documentary
you know to connect it?
लैपटॉप को कनेक्ट करने
हाँ, we tested it, sir.
ऑलरेडी
We've already tested it.
ऑलरेडी कनेक्टेड है.
They have tested it. So as soon as you enter your password, it will start.
How did they know where my computer is?
No, you give them back.
Okay, I see. Okay, terrific. I see. Okay, okay.
Already
terrific.
connected.
I didn't know that they know where my computer is.
ये सेफ हैंड में रखना इनका लैपटॉप थोड़ा
Namaskar. A very good morning to all. Respected dignitaries, distinguished guests, eminent clinicians and academicians, administrative heads of the university, principals, faculty members of the constituent colleges of our university, staff members, and the undergraduate and postgraduate students. On behalf of the Mahatma Gandhi University of Medical Sciences and Technology, it gives me immense pleasure to extend a warm and cordial welcome towards all as we assemble here to witness the third Dr. K.D. Gupta Memorial Oration 2024 that shall be delivered by the renowned endocrinologist and genetist Dr. Nir Barzilai on a very interesting topic, strategies to live healthy to 100 years and beyond. On this occasion, please join me in welcoming the chief guest and today's orator, Professor, Department of Medicine and Genetics and Director, Institute for Aging Research at the Albert Einstein College of Medicine, New York, Dr. Nir Barzilai. May I request you, sir, to please come up on the stage and take your seat on the dais. Amongst your applaud, I also welcome the proud sons of late Dr. K.D. Gupta, renowned cardiologist and academician, Dr. Rajiv Gupta, and his younger brother, renowned hepatologist, professor of medicine and pathology, and the Eliezer and Faiz Riker Chair of Translational Medicine at Albert Einstein College of Medicine, New York, Dr. Sanjeev Gupta. Most respectfully, I welcome the founder and emeritus chairperson of Mahatma Gandhi University of Medical Sciences and Technology, Dr. M.L. Swankar. Please join me in welcoming the chairperson cum Chancellor of Mahatma Gandhi University, Dr. Vikas Chandra Swankar, the Vice Chancellor, Mahatma Gandhi University, Dr. Achal Gulati, and former Vice Chancellor and Chief Advisor to the Chairperson, Dr. Sudhir Sajdev. This oration is being organized by the Mahatma Gandhi University of Medical Sciences and Technology in fond memory of and also as a tribute to one of the most renowned physicians of the state of Rajasthan and of course, international repute, former Principal Sardar Patel Medical College, Bikaner, most revered late Dr. Krishna Dayal Gupta. May I request our chief guest and dignitaries seated on the dais to begin the program by the lamp lighting to give an auspicious beginning to this program. Thank you, all dignitaries. Ladies and gentlemen, as I mentioned, our chief guest and today's orator, Dr. Nir Barzilai. He is Professor, Department of Medicine and Genetics and Director at the Institute for Aging Research at the Albert Einstein College of Medicine, New York. He is also the Ingeborg and Ira Leon Rennert Chair of Aging Research. We welcome you, sir, to our university. When words fall short, flowers make the task easier. To express our greeting towards our chief guest and other dignitaries, it is time now to present them with floral bouquets. And for this, I first and foremost request the founder and emeritus chairperson of Mahatma Gandhi University, Dr. Emil Swankar, to present a floral bouquet and welcome Dr. Nir Barzilai. I also request the chairperson cum Chancellor of our university, Dr. Vikas Chandra Swankar, to welcome Dr. Nir by presenting him with a bouquet. Next, I request the Vice Chancellor of Mahatma Gandhi University, Dr. Achal Gulati, to present a floral bouquet and welcome Dr. Sanjeev Gupta. I request the Chief Advisor to Chairperson cum Chancellor, Dr. Sudhir Sachdev, to present a floral bouquet and welcome Dr. Rajiv Gupta. We also have amongst us seated in the audience Mrs. Laura, the better half of Dr. Nir Barzilai. I would request Mrs. Harman Swankar, if she's there in the auditorium, to please. We also have Mrs. Meena Swankar, the Vice Chairperson of India Education Trust. Ma'am, may I request you to present a bouquet to Mrs. Laura. Mrs. Laura, she is wife of Dr. Nir Barzilai and herself an attorney. We welcome you, ma'am, to our university. Thank you, ma'am. I would now request the chairperson cum Chancellor of our university, Dr. Vikas Chandra Swankar, to formally welcome our chief guest and other dignitaries and deliver the welcome address.
Professor Dr. Nir Barzilai, Chief Guest and the orator of today's program, Chairperson Emeritus Dr. Emil Swankar, Vice Chancellor Dr. Achal Gulati, eminent cardiologist Dr. Rajiv Gupta, Dr. Sanjeev Gupta, Dr. Sudhir Sachdev, distinguished guests in the audience, esteemed faculty members, and my dear students. Good morning and a very warm welcome to each and every one of you. It's my distinct privilege to welcome you to this prestigious Dr. K.D. Gupta Oration, a momentous occasion that celebrates the legacy of an extraordinary teacher, mentor, and healthcare pioneer, Dr. K.D. Gupta. This event stands as a testament to his unmatched contribution to medicine and education, and we are honored to have gathered here today in his memory. As the Chancellor of this university, it fills me with immense pride to welcome you to this significant event, which not only serves as an important occasion for academic enrichment, but also for the celebration of a legacy that has deeply influenced the medical world. It is both humbling and inspiring to reflect on the remarkable life and career of Dr. K.D. Gupta, a renowned emeritus professor of medicine, former head of medicine at Sardar Patel Medical College, Bikaner, and the Dean of Faculty of Medicine at the University of Rajasthan, Jaipur. His contributions to the field of medicine, particularly his work in internal medicine, have left an indelible mark on the profession. Dr. Gupta's exemplary career was characterized not just by his clinical expertise, but also by his profound commitment to education. Today we are privileged to be graced by the presence of an exceptional individual, Dr. Nir Barzilai, who will be delivering this year's Dr. K.D. Gupta Oration on the topic Strategies to Live Healthy to 100 Years and Beyond. Dr. Barzilai is an internationally renowned physician, researcher, and a medical entrepreneur whose work has revolutionized the field of aging and longevity. Currently serving as the director of the Institute of Aging Research at Albert Einstein College of Medicine, Professor Barzilai's groundbreaking research on biology of aging has placed him at the forefront of one of the most exciting areas of medical sciences today. His studies on longevity genes, the genetic factors that influence aging, and his exploration into potential of metformin as a tool for extending human lifespan have made significant contributions to our understanding on how we can lead healthier and longer lives. I think this has been the human endeavor since humanity was born, to reverse aging. Professor Barzilai's research, particularly his role in leading Longevity Genes Project, which studies the genetics of centenarians, has provided profound insights into how certain genes protect individuals from major age-related diseases, including the cardiovascular disease, cancers, type 2 diabetes, dementia, and so on. This work holds great promise, not only for increasing lifespan, but also for improving the quality of life as we age, which is a topic of great significance to each and every one of us. He is leading an international effort to approve drugs that target aging. Targeting aging with metformin, TAME, T-A-M-E, is a specific study conceived by Dr. Barzilai to prove the concept that a single drug can combat multiple diseases associated with aging and to get FDA approval for targeting aging. Dr. Barzilai is the founder and president of the Academy for Health and Lifespan Research, AHLS. He is also on the American Federation for Aging Research Board of Directors, where he co-leads the biomarker effort FAST, TAME, and Super Agers Initiative. He is an executive of the Longevity Biotech Association and serves on the Council of Healthy Longevity Medicine Society. He authored many books like Age Later, Health Span, Lifespan, and the New Science of Longevity. As we listen to Professor Barzilai's address on the strategies for healthy aging, let us remember that the pursuit of health and longevity is not only a scientific endeavor, but also a deeply personal one. It is a pursuit that touches every life, every family, and every community. It is a reminder that work we do as healthcare professionals has the power to transform lives and shape the future of the society. Sir, I would like to utilize this opportunity to submit a brief introduction about our university, though you have had a brief round of the hospital before coming to the oration. Mahatma Gandhi University of Medical Sciences and Technology, Jaipur, stands as a beacon of excellence in medical education and healthcare delivery, established under the auspices of the Rajasthan State Assembly in 2011. The institute initially began as a medical college in the year 2000 and evolved into a full-fledged university in the year 2011. At the heart of the Mahatma Gandhi University lies the Mahatma Gandhi Hospital, a nationally accredited teaching hospital and the largest private healthcare facility in Rajasthan with over 1450 beds. The hospital has been a pioneer in organ transplantation, having performed groundbreaking procedures such as the first heart transplant, first liver transplant, first pancreas transplant, and first cadaveric kidney transplant in Rajasthan. With more than 2100 successful kidney transplants to its credit and more than 120 liver transplants, Mahatma Gandhi Hospital's digestive sciences and renal transplantation teams have set benchmarks in clinical excellence. Shri Ram Cancer and Super Speciality Center, affiliated to the university, stands as the state's largest multidisciplinary oncology facility, equipped with latest technology like Da Vinci robotic surgery, cyber knife, linear accelerators, 3 Tesla MRI, 2 PET scans, etc. to name a few, and is managed by very eminent and learned faculty in their fields. The center's comprehensive services include advanced radiation oncology, bone marrow transplantation, and a state-of-the-art blood bank accredited by the American Association of Blood Banking. Similarly, the Center for Neurosciences and Cardiac Sciences, led by very competent doctors, performs complex procedures using the latest equipment, further enhancing university's reputation as a hub for academic excellence and advanced medical care. Amid the COVID-19 pandemic, Mahatma Gandhi Hospital emerged as a pivotal COVID center in Rajasthan. It was the largest privately owned COVID care facility with over 1,000 oxygen beds and close to 400 ICU beds, managing thousands of patients and conducting hundreds of thousands of RT-PCR tests during the COVID-19 pandemic. With recognition from the national bodies like the National Medical Commission and the Government of India, the university offers a diverse range of undergraduate, postgraduate, super specialty programs, subspecialty as you call it in the United States, attracting students seeking quality education and healthcare professionals dedicated to excellence. Through partnerships with state healthcare schemes, the university ensures universal access to high-quality healthcare, emphasizing commitment to service, quality, and patient-centered care. I would like to express my heartfelt gratitude to Dr. Nir Barzilai for accepting our invitation and also accepting the invitation of the Gupta family, Dr. Rajiv Gupta sir and Dr. Sanjeev Gupta ji, to deliver this prestigious oration. We are honored to have you with us today, and we eagerly look forward to the insights that you will share. I would also like to thank the faculty, staff, students, and guests present today for your unwavering support, for sparing time, and your continued commitment to the pursuit of excellence in the field of medicine. Thank you once again. I welcome you all to the K.D. Gupta Oration. May this day inspire each one of us to continue striving for betterment of human health and well-being of all. I look forward to a thought-provoking and enriching lecture from Dr. Barzilai. Thank you. Jai Hind. God bless us all.
Thank you, sir. Born on October 12, 1922, Dr. K.D. Gupta graduated from King Edward Medical College, Lahore, and thereafter obtained his postgraduate degree from the Government Medical College, Punjab University, in the year 1949. He started his academic career in 1951 from the SMS Medical College, Jaipur, and later joined the Sardar Patel Medical College, Bikaner, where he became the principal. Throughout his professional tenure, Dr. Gupta was recognized as a brilliant teacher, outstanding clinician, and an able administrator. I take pride in sharing that Dr. K.D. Gupta was a major guiding force in the establishment of our institution. As a tribute to this astute academician, the Central Library of Mahatma Gandhi University is named as the Dr. K.D. Gupta Knowledge Resource Center. And to commemorate his birth centenary in the year 2022, this series of orations was introduced at our university. I would now like to invite renowned preventive cardiologist and son of Dr. K.D. Gupta, Dr. Rajiv Gupta, to throw light on Dr. Gupta's journey of life through a documentary, and would also request him to introduce our orator, Dr. Nir Barzilai.
Thank you, and thank you, friends. My introduction to Nir Barzilai was through a book. I read his book years later actually. I've been reading book on increasing longevity, which I want to translate to my patients actually. So I read David Sinclair and your book, and then I thought, why not we have this sort of science, the new science of the aging and preventing aging actually into India, and no better person than Professor Barzilai. Professor K.D. Gupta, my father, was a living example of how to age later. And even at the age of 82, 83, before he passed away because of complications of heart failure, he was very active, and Dr. Swankar Mohanlalji will know that on just the day before, he met and he listened to songs and music and Shiv Stuti. It was Mahashivratri actually. So he told him everything, and I think that's the ultimate aim of that we should live happy and healthy throughout our lifespan. So I think we'll have a short documentary from our family as a tribute to Professor K.D. Gupta. I won't spend much time here. Thank you very much for coming. Thank you.
Dr. K.D. Gupta was one of the most senior and distinguished physicians in Rajasthan who received his primary education in the village of Ballabgarh, Haryana, and completed his secondary education at the Government High School at the district headquarters of Gurgaon in the late 1930s. He then went to Lahore for further studies, which was a major educational and cultural center in North India. Dr. Gupta excelled in his studies at the DAV College in Lahore and was considered to be one of the most successful and brilliant students at the college. Subsequently, he was accepted at the King Edward Medical College in Lahore and graduated from there in 1946. Immediately after becoming a physician, he joined the provincial medical services of the Bikaner state, where he quickly made a mark in the presence of outstanding physicians led by the Venerable Professor Weingarten of tropical eosinophilia fame. This experience enthused him to obtain further expertise, and in 1950 he obtained an MD degree from Punjab University and joined the Rajasthan State Medical Services and was posted as a medical specialist in Kota. In 1952, he joined as a lecturer at the Department of Medicine at the newly established SMS Medical College, Jaipur, which was the first medical college in the state and was affiliated with the Rajasthan University. He had the distinction of teaching the first graduating class of the SMS Medical College and made a mark with an original style of teaching and was renowned for his clinical acumen and academic depth and breadth. In 1956, Dr. Gupta was awarded the prestigious Lederle International Fellowship in Allergy and Immunology and worked at St. Mary's Hospital, London and the Temple University, Philadelphia for 2 years. This overseas experience in academic medicine became an important forming event in Dr. Gupta's career. Upon his return, he started the first allergy clinic in India at the SMS Hospital in Jaipur, which was later taken up by other institutions in the country. In 1962, he was appointed professor and head of the Department of Medicine at the SP Medical College, Bikaner, where he went on to become the principal of the college and the Dean of Medical Studies at the University of Rajasthan. In 1977, he retired from governmental positions after having completed 31 years of highly distinguished service. Dr. Gupta had a lifelong involvement in basic and clinical research and had over 200 publications in fields of allergy and immunology, liver disease, and cardiovascular pathophysiology in national and international journals. His hypothesis of infections as a cause of chronic liver disease and gut-liver interaction is still a hot topic in hepatology. He was honored by several fellowships, state and national awards. He was an extremely popular teacher, and his lectures and bedside teaching methods inspired thousands of undergraduate and postgraduate students who remember his legendary clinical teaching and interpersonal skills. These students are spread not just in India, but far and wide across the globe. He was extraordinarily popular as a friend of students and an avid supporter of cultural activities, and his students still remember his captivating voice and mesmerizing rendering of songs and ghazals, which were an ever popular star attraction at annual functions and picnics of the medical college. Students still remember the annual Holi festivities at his home with songs, dancing and gulab jamuns. After retiring, he settled in Jaipur as a consultant physician and was appointed as an emeritus professor by the government of Rajasthan. Moreover, he served as the chairman of the Rajasthan Red Cross, established the very first private blood bank in Rajasthan, and was also a guiding light in the setting up of the first private medical college, the Mahatma Gandhi Institute of Medical Sciences in the state, where the Central Library has been named after him. He remained busy until the very end with his clinical activities. For Dr. K.D. Gupta, his family and his extended family of students were his pride and joy, and he loved to meet and sing and laugh with them till the very end.
Thank you.
It was indeed heart-touching and nostalgic. As we proceed further, I would now like to invite Dr. Sanjeev Gupta, the Professor of Medicine and Pathology at Albert Einstein College of Medicine, and also the Eliezer and Faiz Riker Chair of Translational Medicine, to read the citation for Dr. Nir Barzilai.
So it is a moment of great honor and privilege for me to be here and to welcome once again all of you who have come from far and near, including our elders, friends, colleagues, and everyone else. And it is my distinct privilege to read this citation, which I have not seen before, but it looks long, Nir, and it's important, of course, that you're here. But before I begin reading it, I have to say something about Nir, because we go back a long ways. Nir came to us at Einstein having had a very interesting journey that began in Israel. He was born in Israel, grew up there, went to school, went to medical school, but before that he had to go to the Israeli army as well, because it was required. So he spent 2 years there, at least, I think, and had significant impact even then, because he was working as a paramedic with the IDF, contributing to some of the newer ways for trauma management, instrumental in developing that early evacuation from the battlefield and the criticality of the first 1 hour in that process of trauma for salvage and rescue and life-saving. And I think that's where he began to think more deeply as to how lifespan must be enhanced, not just for a few hours, days, weeks, and months, but for decades. And then I think, whether he knew it or not, he began to understand how different educational opportunities and training and preparation is key to building new knowledge for innovation, and by learning at the feet of masters is how one begins to inculcate those capabilities. And so Nir came out from Israel, from Technion is where he did his initial education, and then in other major medical centers, residency and so on. But then he began to acquire fellowship experience, went to London, and his first foray in sorts of clinical sciences was with someone who you have read about, Sheila Sherlock, at Royal Free. And his initial work began with the liver, where he told me his interactions with Sheila Sherlock once when she said, "What is the purpose of liver?" And he raised his hand and he says, "Making glucose." And that's where then not only did he impress Sheila Sherlock or raised her ire, I'm not sure, but that's what began his journey. And lo and behold, later on he comes to New York and lands up at Einstein in the Bronx, not because that was the most significant part of New York City, but because there was intellectual gathering of the right type. And so he then began to learn about diabetes, to learn about other things. And then he realized that the central question in life is aging. The central question in life is prolonging life itself. And that's what began the journey that has led him to be here. We have intersected in many ways. We've been both at Einstein now for more than 30 years. But over all those 30 years, other than the initial part where he shared the space with his mentor that I occupied later, we did not interact at that time. But our real interaction, in fact, happened years later, once when we were involved in the strategic planning of Einstein as a college and its activities, and later on, more recently in our educational missions of mentoring and other things. But across the years, then not only has Nir been an outstanding physician scientist, he has been a mentor for countless number of people who have gone on to build their own research careers. And he's become an international presence, not by just forcing his way in, but by creating new thoughts. And as a thought leader in the field of aging, he has made enormous contributions, among which have been bringing in millions of dollars of money to Einstein, which has elevated his status, no doubt, beyond imagination at Einstein. I'm just kidding. But his overall efforts internationally in putting aging at the forefront really has led him to be featured in National Geographic, along with various birds and beasts and bees. I'm sure Nir is very proud of it. And across the world of journalism and so on as well. So when I went to his office to invite him to do this oration, he said, absolutely. And then it took us 2 years to get him here, because he is in so much demand. But I'm so happy that his wife, Mrs. Nir Barzilai, is here, has joined him here as well across the seas. And we have come to know them both much more in the past few months with our dinners at home. And we hope to continue that tradition now that we have started it. But Nir, so thank you, Nir, to be here, to make that effort. And we are, of course, going to be looking forward to your oration. But here is a citation that you'll receive as the award for being here. And as part of this citation, as I said, I haven't read this before, so I'm going to not go through this entirely all across, but parts of it I'll skip. The citation says that Dr. Nir Barzilai is being honored and this honor is being presented by the chairperson cum chancellor, the vice chancellor, members of the board of management of the university, and Dr. M.L. Swarnkar, founder and emeritus chairperson, Mahatma Gandhi University of Medical Science and Technology, Dr. Nir Barzilai, MD, the Ingeborg and Ira Leon Rennert Chair of Aging Research, Director, Institute for Aging Research, which he founded, Professor, Departments of Medicine, Endocrinology, and Genetics, Albert Einstein College of Medicine, Bronx, New York, for having delivered the third Dr. K. Gupta Memorial Oration 2024 on strategies to live healthy to 100 years and beyond on Saturday, December 14th, 2024. So that is what we will be hearing about. Dr. Nir Barzilai, a leading pioneer, a renowned physician in medicine and genetics, a gifted teacher, an avid researcher, and a medical entrepreneur in the Ingeborg and Ira Leon Rennert Chair of Aging Research, etc. Born in Israel in 1955, Dr. Barzilai got educated at Israeli School for Military Medicine, which then, as you just heard, led to his contributions to IDF. And among those contributions, in fact, was his participation in the Entebbe raid that rescued Israeli hostages from one of the unfortunate incidents out in Europe. So he was a summer student at Baylor College of Medicine, Houston, Texas. He did clerkship in South Africa in two separate institutions, including the Baragwanath Hospital. That's not part of the citation, I'm just amplifying it a little bit. And his MD at Haifa in Israel, internship in Israel and London, completed residency in internal medicine at Hadassah Medical Center in Jerusalem, and then the Royal Free Hospital, London. He first came to the US in 1987 as a resident at Yale University and joined Einstein in 1993 as an instructor of medicine and endocrinology. He has completed two fellowships, one in metabolism at Yale and another in endocrinology and molecular medicine at Cornell. He is an advisor for the Prime Minister of Singapore on aging, the former Prime Minister, I presume. He did not age well in his career. Current one. Okay. His work has been profiled by major outlets, including the New York Times and the BBC. Dr. Barzilai is the director of the Longevity Genes Project, a genetics study of over 2,600, including 670 families of centenarians and their children. The participants are all Ashkenazi Jews. He found that many of the centenarians had very high levels of HDL. He has discovered several longevity genes in humans. These genes appear to protect centenarians against major age-related diseases such as cardiovascular, cancer, type 2 diabetes, and dementia. In addition to his longevity gene research, Dr. Barzilai studied key mechanisms involved in the biology of aging, including how nutrients and genetics influence by lifespan. He proposed metformin as a tool to target aging. He is also investigating how mental decline and personality affect longevity. And he believes that metformin will extend human lifespan. Dr. Barzilai has been the recipient of numerous grants, including those from the National Institute on Aging, American Federation for Aging Research, the Ellison Medical Foundation, and the Glenn Medical Foundation. He has published over 280 peer-reviewed papers, reviews, and textbook chapters. He serves on several editorial boards and is a reviewer for numerous journals. Dr. Barzilai is on the board of the American Federation of Aging Research. He is co-founder of COBAN, which is spelled as COHBAR, Inc., a biotechnology company developing mitochondria-based therapeutics to treat diseases associated with aging. Dr. Barzilai has been the recipient of numerous prestigious awards, including the Beeson Fellow for Aging Research Award, the Allison Medical Foundation Senior Scholar in Aging Award, the Paul Glenn Foundation Award, the National Institute on Aging Nathan Schock Award, the 2010 Irving S. Wright Award of Distinction in Aging Research, and the Ibsen Longevity Prize. He is currently leading an international effort to approve drugs that can target aging. Targeting aging with metformin is a specific study designed to prove the concept that multiple morbidities of aging can be delayed by metformin. Working with the Food and Drug Administration to approve this approach will serve as a template for future efforts to delay aging by medications, that's in parentheses, and its diseases in human beings. At the bottom, the signatories are Dr. Vikas Chandra Swarnkar, Chairperson cum Chancellor, and Dr. Achal Gulati, Vice Chancellor. And I'm glad to see Dr. Swarnkar is right here on the stage, and Dr. Rajiv Gupta is there as well. So those awards are not mine. They're all in this big citation. I should make a couple more comments as well. All right, so just one more second. And so Nir, thank you again for accepting our invitation. We are really looking forward to your oration and to learn more about what more is to come across the decades. And thank you all for being here as well.
Is that on the right? That's not holding. Perfect. Thank you so much. I want to just say something. I was so bored to hear about myself. I'm so excited now to actually start talking. But it's very important for you young people, and I think the young people is at the back, they're not in the front. I want you to know that what I heard is my age. So what you're going to achieve, you're going to achieve much more than that. You're living in an exciting time, and you're going to discover a lot of stuff, and I'm just jealous of you. I also want to thank very much you guys and your family, mainly the Swarnkar family and the Gupta family. You're a great host, and it's just a privilege and pleasure to be here in this occasion. And I just had a tour of the hospital, and it was so, do I need something? The hospital was so incredible. I don't think that our hospital that is considered very good has the technology that you have. And for me, it was more like visiting the Mayo Clinic. So now if somebody in the East is asking me where to go, it's to Jaipur, to your institution. So let me see now if I can actually, show my slides. You'll notice that I changed, oh, it doesn't. You notice now that I've, still not going? Oh, here, yeah, it's here. That I've changed the title of my slide to How to Die Young at a Very Old Age. So it'll have more of a practical approach. But it's especially gratifying for me to be for this specific oration. And I asked the Gupta family to provide me with a picture of Dr. Gupta where he was already old but still very robust. Apparently he was 75 years old here, taking a little break from a hike with Mrs. Gupta and their grandkids, Sanchit and Sonika. I know Sonika she's a very great young lady. My father was the founding dean of a medical school in Israel, and he was also a great man, and I feel just the kinship of having great fathers for children who have been very successful, and I'm sure that just as my father saw his legacy in me, your father couldn't have been more proud of you guys. And I'm sure that you know that, but I know that it's true. Okay, so let me now just bring you to my life with the following story. A 100-year-old gentleman walks into the National Life Insurance in Jaipur, to their main building, and he says, I want life insurance. And the clerks laugh and says, we don't give insurance to 100 years old. And he said, but that's not true, because my mother is 120 years old and she's insured here. Is she healthy? Yes, she's healthy. So the clerk thinks for a second, he goes to the boss, they're talking about it, and they said, you know, that's a good marketing for us. And they come to the old gentleman and they say, you know what? We'll be happy to give you life insurance. In fact, come on Tuesday and we'll have everything ready. You'll just have to sign. And the old gentleman says, I'm sorry, I'm busy on Tuesday. They say, what happening on Tuesday? He said, on Tuesday, my grandfather is getting married. How old is your grandfather? He said, he's 150. He said, he's 150 and he wants to get married? He said, he doesn't want to, but his parents puts lots of pressure on him. Okay, you'll understand why this is for me a relevant story, but I want to also point out to the fact that if we'll be successful and if we'll live 150 years, do we want our parents still to push us? Okay, there's always trade-offs. So this is what I found in the internet. This guy from Jaipur apparently died when he was 127 years. We don't know, the only validated person in the world that lived over 120 was a 122-year-old, Madame Clement in France. It's possible that he lived to 127, but statistically, human lifespan, maximal human lifespan for us as a species, 115 years. It doesn't mean that we wouldn't be able to break it, but you know, we die before the age of 80 or 70. Half of us die. So there are 35 years that we can start to realize, and this talk is about how we can realize it right now and much better. Much more famous. Do you want me to talk here, maybe? Because I hear my echoes, so is that good? Okay. Much more famous is this guy. I see him all over. He's an Indian, but he lives in England, and he's a marathon runner. He ran the marathon at age 102. I think this picture was taken when he was in his 90s. But the point is that there are people, including Indian people, with very exceptional longevity. So what is the problem? So look, life expectancy in our human evolution, okay, 100,000 or so, we argue about it, was 20 to 30 years throughout evolution. It's really only in the last 150 years, that's why it looks so steep, that we basically tripled our life expectancy, which is now decreasing in the United States, and it's 76 years, and it's increasing in India, and it's 71 years. But when this happened, what we started getting is that people after the age of 60 are getting disease after disease. The diseases are bad. There's treatment for those diseases. Some of the treatment is antagonistic. And we start accumulating the diseases and end in bad quality of life. Please remember that the major things that happened in those 150 years has to do with prevention. We harnessed agriculture, we cleaned the water, we built sewers, we have vaccination. A lot of the public health impact were on prevention. And we need to remember this because this prevention thing is what we need to do about aging too. So basically, we need to create a new history for us where by prevention we'll stop the process of aging. So what do we know about aging? First of all, we all know that aging has a biology, right? We know who's old and who's young. And I'll tell you, when I was a resident in the hospital, my attending always said, when we introduce a case, if I would say this is a 57-year-old woman, he will stop me and says, does she look older or younger than her age? There is a chronological age and biological age. And you in the hospital and people out of the hospital, they know. You look at your parents and their friends and you know that some are aging faster than others. Okay, so by that fact, you know that there's a biology of aging, and by the fact that you know it's a biology of aging, you can ask, okay, why is it? Why some people are aging faster or slower? Let's understand that, and maybe it's useful for us. What we've studied is this biology of aging is what drives diseases. Okay, it's kind of commonly believed that you get disease and get old. No, it's actually this biology of aging that drives diseases. And that means that if you want to do something about the disease, you target the biology of aging to prevent the disease. Look, you can be born and being, by the way, I know that not everybody is a medical profession, and I'll go from here to there, bear with me, I'll always talk simply enough, okay? But I'm going to throw things that some of you don't know. But you can have an ApoE genotype, and if you're homozygous, you have real good chances of getting Alzheimer when you're 60 or 70 and die when you're 80. But when you're born with this genotype, you're not demented, and not when you're a year old, and not when you're 10 years, or 40 years, or 60 years. It needs the aging process to happen. And I could do the same talk for every one of those diseases. You need the biology of aging, and the good news is that aging can be targeted. We've done it on many models, on mammalians, across the world, also with some drugs. We'll show you the data on that. And we can really kind of stop the process of aging, and in some cases even reverse, stop it totally and reverse that. So with this knowledge, what we call the geroscience revolution is that we need to spend time on maximizing our health, okay? Do the prevention rather than spend our time treating a disease. And this is what I'm going to show you in bits and pieces or in provocation in the next several minutes. So first of all, what we have in the biology is something that we call the hallmarks of aging. And I'm telling you already, I'm not going to go through all those hallmarks of aging. But in order to be a hallmark of aging, you have to show that it happens with aging, and if you prevent it, your animal is going to live healthier and longer, or if you're human, you're going to have less disease and less mortality, overall mortality. The interesting thing with those hallmarks of aging, they are interconnected to each other in the sense that when you treat one of them, you also improve the other. Okay, and that's why you can treat one of them and get increase in health span and lifespan. You don't have to do all of it together. Now, I'm not saying that it wouldn't be great to have all of this together, but you don't. And this is very important. And also, I'll have to show you that it's true. For example, I have to show you that one of those hallmarks is decline in metabolism, that it's also going to improve the decline in immunity that you see in aging, because they're all connected to each other. And now I'm going to do it by two examples. And the first thing is with my population that has 700 centenarians and their offspring and the people who are married to their offspring. And this is an example, this is our poster child. Those are 4 siblings that were born to 2 parents between 1910 and 1920 in New York City. And what's impressive with them is all of them passed the age of 102. So it makes 2 points, okay? Not only the longevity, but also the genetic association of longevity. I mean, what are the chances that people who were born 1910, 1920 will live so long? In fact, the woman here, okay, you see my time, Helen, she died at 110. I saw her in New York City apartment when she was 100 years old. She opened the door to me and she was smoking. And I said, Helen, nobody told you to stop smoking? And she looked at me and said, you know, the 4 doctors that told me to stop smoking, they all died. And I'll tell you why this point is important. She continued to smoke for 10 years and died at 110. But really, the major question for us was, okay, are those people, those 100 years old, do they get sick when we all get sick when we're 60, and now they're just having more years of disease, or is their health span and lifespan, does it go together? And this is one of our papers. And you see here 2 groups of people, it's different studies, but those guys are our control and those guys are our centenarians. And you see that everybody is healthy initially. Our control after the age of 60 started to accumulating diseases, and only 10% of them don't have disease when they are 80. On the other hand, our centenarians are healthy, 20, 30 years longer. And even at age 100, 30% of them don't have any disease. So it's not only that they live longer, they live healthier. But you know what? This is not the exciting thing. The exciting thing is that they have what we call a contraction of morbidity. They're sick very little at the end of their life. Those 30% probably will not wake up one morning, or they will have a short hospitalization. And so we started talking about, we started to ask, what does it mean? You know, what does it mean to live healthy, 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 and to die? First of all, it's an example, okay? We have people like that, okay? It's within our power. You live healthy, healthy, and die. The CDC, the American Central Disease Control, have looked at the medical cost in the last 2 years of life of somebody who died over the age of 100, and it's 1/3 of those who dies before. So it's confirmed. It's not only in our study, it's confirmed. Those guys don't have much medical care. And this is kind of the concept of longevity dividend. But it's more important than that. An economist from London Business School, Andrew Scott, said, guys, you don't know what you're saying even. And we said, what do you mean? He said, you're talking about those guys are not in the hospital. But if they're not in the hospital, where are they? They're traveling, they're shopping, they're building houses or hospitals, I don't know. So they have an economical value. And the economical value is amazing. He published, if we add 1 or 2 years of health span, it's $360 trillion to the world economy. In other words, we cannot afford not to do it. If we can stop diseases of aging, we cannot afford not to do it, okay? And we have to do it right now. So let me, you know what, I think I'll skip, I was going to show a film here, but I think I'll skip it because I think time is running late and it's not necessary. I'll move to, okay, so if they're 100 years old, we have 3 hypotheses. One of them is, they knew exactly what to do, what to exercise, what to eat, how to sleep, how to be socially connected, everything. Okay, that's hypothesis 1. If we all adopt it, we have a chances to get to 100. Another hypothesis, because this is the age of genetics, and we saw that it's in the family, maybe, we have a lot of changes in our DNA, in our genome, that are risk for diseases, for Alzheimer's, for heart, for Parkinson, for, diabetes, cancer. Maybe those people, 1 out of 10,000, let's say, have like perfect genome. They don't have any of this stuff, okay? And that's why they're healthy. And a third hypothesis is that they actually have genes or changes in the genes that slows their aging process. So let me very fast just show you in one slide the results of each of these hypotheses. So the first one is interaction with the environment. So overweight or obese is almost 50% of them. Smoking, 60% of the men, 30% of the women. Physical activity, and I'm talking even about moderate, like walking or housework, less than 50% of them. Vegetarian, 2.6% of them. And by the way, we know their cohort at that time, how they were doing, and they were doing similar or better than our centenarians. And the bottom line is that our centenarians as a group didn't do what we think people should do with the environment. Be lean, not smoke, and everything like that. It's in spite of that. That's not their secret. It's still your secret, okay, but not their secret. They didn't need that. That's why Helen could smoke, right, when she was 100 years old. Do they have the perfect genome? Well, we looked, at early days where we got the whole genome sequencing of 44 centenarians. Not control yet, okay, only our 44 centenarians. And at that time, there was a database that's called CleanVar, still exists. At that time, it had 15,000 pathogenic variants, which mean 15,000 pathogenic variants that each one of them, if you have, are likely to give you a disease. The numbers are greater now. And so the hypothesis, remember, is that our centenarians will be clean. It's not only they're not clean. In 44 centenarians, we saw over 230 SNPs that should have made them sick. And they're 100 years old and they're not sick. Everyone has 5 to 6 genes that should have made them sick. And they're significant. I told you about the Alzheimer genotypes. We have people who are 100 years old that are homozygous for ApoE4, and they're not dead and they're not demented. And other degenerative disease and neoplastic disease and cardiac disease, all kind of disease. Okay? And it's not them. So the next hypothesis, if it's not the environment, if they don't have a perfect genome, do they have genes that slows their aging? And just for the students and young faculty, I'll just say in one slide, or in the next 2 slides, what we did. And I really want to say one thing. We are in the days of omics. We are in the days of computational, of AI. And that's how we do the research. And we have exome sequencing of thousands of people, among them of 700 centenarians. And the data is coming in. But the data is useless if you don't know to ask the question. I'm always giving the example of a company that had electronic records of 20 years for 3 million people. And they discovered that obesity is a risk for diabetes. I didn't need AI for that. We knew that for 8 years, okay? So you have to ask the right question, and you have to ask the right question right. Now, the genetic study used to be, let's look at changes in your genome and compare it to, and ask, do you have a disease? So we take 10,000 of people, and we looked at one SNP, one change, right? And with one change, we said, do you have diabetes or not? But we are not built from one change. Each one of us has many changes. And those changes could be also in the same pathways. So we need to be much more clever how we are asking the question. And in this case, we have the whole exome sequencing, and we take rare SNPs, and we looked, what are the rare SNPs? But we don't stop there. What we do then is ask, in which pathway are there? So we can put them in pathways, and by putting them in pathways, we get more relevance of which pathways are important for longevity. Long story, at the end, our top candidates were some things, okay, those are the difference between centenarians and people who are not related to them. The major hits were on things what we know are involved in aging. We knew it from animal models, from human studies. It was on the IGF insulin signaling, it was on mTOR signaling pathway. But the point is, we kind of understand the centenarians on a genetic level. And I want to talk about this one example of the growth hormone IGF-1 signaling, because 60% of our centenarians have something wrong in the signaling pathway. Okay, now, there's one growth hormone, but there's a lot of growth hormones. There are actually hundreds of growth hormones. So growth hormone is a major growth hormone, and it has its action, but one of its action is to increase IGF-1, which is another growth hormone. Okay, that's all you need to know for now. But this is what's interesting. You know, the small dogs live longer than the large dogs. The ponies live longer than the thoroughbreds. When we mutate the growth hormone pathway in nematodes, which is a really nice laboratory tool, they live much longer. When we give mice, either we implant them genetically with growth hormone or we knock it out, those who knocks out live significantly longer, and those that have growth hormone live shorter. Even centenarian, they're already 100 years old, and when we ask them, when we see who's going to die before whom, those with the lowest IGF-1 are going to live the longest, twice as long, okay? So we have all the evidence that if we have less growth hormone, it's good for longevity. How can we explain that? Okay, how can we explain it? Well, there is antagonistic pleiotrophy theory of aging that says what's good for you when you're young is not necessarily good for you when you're old. You know, you need cholesterol when you're young because you need to build your body, your cells, your gonads. But if you have high cholesterol metabolism when you're old, you get coronary disease, right? So that's an example for antagonism. What about the growth hormone? Well, this is a study that we did using UK Biobank. And basically, the UK Biobank had over 250,000 IGF-1 level and clinical data. And we asked the data from the UK Biobank, if you have a high IGF-1 level, what happens to you? When you're young and when you're old. And when you're young, you're protected from mortality, from dementia, from diabetes, from vascular disease, from osteoporosis. You're protected. And when you're old, it switches. The same high IGF-1 level all of a sudden cause you all of those diseases. Okay, this is antagonist pleiotropism. And simply the reason for that is when we start breaking down because we age, it doesn't make sense for us to grow. This is not a good energy. We have to turn our energy to defend our breakdown. Okay, that's why lowest IGF-1 level is better. I already told you that centenarians with the lowest IGF-1 level live twice as long. But also that centenarians women with the lowest IGF-1 level have much better cognitive function. And it's more than male, in female than male, but we have less males. And also muscle function doesn't change. In other words, the trade-offs of low IGF are also benefiting the aging of other organs. Now, how do we make it a therapy? How do we use this knowledge? So the example here is that antibody against IGF receptor. Okay, so there's the IGF and it acts through a receptor. And there was several pharmaceuticals have IGF receptor antibodies that you inject just once a week. And they used it with the hope to treat cancer because cancers have a lot of IGF-1 receptors. And they failed because cancers are smart. And by the way, we want to prevent cancers, right? Not to treat cancer. We think it's easier. So we took those IGF receptor antibody, murinaized them, and we gave it to animals who are old already. And as you see, this is everybody is alive, and by here everybody is dead, but those that got those antibodies live 10% longer. But it's even more dramatic how their cardiac function, exercise capacity, and sensory motor function were so much younger. And also, it's important to know that it's really never too late to target aging. It's the same mechanism. It starts when you're younger, but it's the same mechanism. So the fact that you're old, even if you have disease, doesn't mean that you don't want to prevent the next disease. Okay. So this is the knowledge from centenarians. Now I want to speak about what we can do. And it's often that people will come to me or my colleagues and say, prescribe me something. I wrote it as gerotherapeutic, but this is treatment, right treatment for aging. And there are longevity doctors and there are longevity clinics and there are longevity clinics in public hospital. Maybe there'll be one here too. And the first answer for everyone at every age is you can optimize, okay, or maximize any one of those, the exercise, the diet, sleep, and social connectivity. For example, with diets, there are several options. Okay, I'm not sure they're good in India, but there's a Mediterranean diet, there's low carbohydrate diet, there's intermittent fasting, there's a lot of way to look at it, and that's not my lecture is about. Sleep, you know, you should be in a dark room for 8 hours without electronics. And, you know, some of us will sleep only 6 hours, but that's also good. And social connectivity is really important. We learned also from COVID that the isolation of COVID had a price. So those are all things that we should do. And I'm not going to go deep into them. I want to make one remark about supplements. Because usually, people who are already maximized, they said, okay, which supplement to take? And I will tell you something very interesting that I know that the medical people here and the medical student knows. For supplements, there's no clinical data usually. There's no clinical study because the FDA in the United States and all over the world will let you sell supplements without clinical studies. Okay, so it's all based on hope, even not promise. Okay, it's based on hope. We don't know much about supplement. In fact, there was a recent JAMA net paper that followed 7 million people for 12 years. 7 million for 12 years. And the people who were on multi-supplements had 4% increase in mortality. This is very surprising because people who take multi-supplement also do the other things usually. They also exercise and they take good care of their health. So supplements are not necessarily additive, they're not necessarily synergistic. In fact, I'm afraid that some of them are antagonistic. And I think people who take 150 supplements and advertise it are really crazy and they're dangerous to you. Okay? So supplement, for me, is a problem. But there are FDA-approved drugs, not for aging, for other diseases, that were given to animals and they show to increase lifespan of animals. And I'll show you in a second, but the reason it's FDA-approved drugs is because we want longevity to be handled, at least initially, by doctors. Okay? We don't want other people to suggest. We want the doctors because the doctors are responsible, conservative, and they will monitor you. But remember, if it's FDA-approved drug, it passed the safety, it passed the efficacy, and there's years of follow-up. So it gives us opportunity to really accelerate what we know. Now, in order to judge if something is a gerotherapeutics, I suggest we have to look at two things. We have to look at the preclinical data. And the first thing on the preclinical data, do they target those hallmarks of aging that I showed you before? And by the way, if you have a real good gerotherapeutic, it will target a lot of those aging, because that's how it works. You know, you give something for something and it improves the other. So, for example, statins, that are very important drugs for lipid management, if you give them to animals, they don't live longer. Okay? So they're very important to prevent coronary disease, but they're not stopping your aging in any way. So we look for drugs that are on the hallmark of aging. The second thing is we look for drugs that extends the lifespan and also the health span of the animal. So this is the preclinical, like you develop any other drug. In the clinical, I would ask for two things. Does this drug that is given for a certain indication, does it prevent other diseases? Not the one that we're indicated for, but other diseases. And not one other diseases, more than one other diseases. And just similarly, in a clinical study, it's all in clinical studies. In clinical studies versus placebo, is your drug that also prevents multimorbidities also decrease not disease-specific mortality, but overall mortality? And I think if you have evidence for that, you are pretty much can start testing this drug. So we took all the animals that live longer while they're getting FDA-approved drug, and we had the 12 points total, 6 for the preclinical and 6 for the clinical points. And you see here in pink the ones that got 11 and 12. Okay, in fact, all of them got all the clinical points. Okay, all the clinical points. Now, it ends up with rapamycin. Rapamycin is used as immunosuppression in high dose for organ transplants. But if you give rapamycin in lower dose to all animals in the world, nematodes, flies, mice, rats, they would live much healthier and much longer. We just don't have enough evidence in humans. So it's not one of those pinks. But those pinks are SGLT2 inhibitors, I don't know the name that you're using in India. Metformin. Metformin is the world metformin is basically manufactured in India. Biphosphonates for osteoporosis, and GLP-1 receptor agonist, or Ozempic, or whatever, again, the Indian name is. All those have evidence that although they were designed for one disease, they affect many others and mortality. So I'm giving you a really quick tour. I'll start just with, another thing. So, for example, those 4 examples are FDA-approved drugs that in clinical trials have shown to prevent hospitalization, death, and long COVID. Okay? So think of metformin, that is thought to be anti-diabetic drug. It's not. It's really mainly an aging drug, but okay, changed metabolism. And around the world during COVID, it was noticed that people on metformin don't die. They were mostly diabetics. And then New England Journal of Medicine have shown in a study, on a clinical study, that if you take metformin within the first few days of COVID, half of the hospitalization, death, and long COVID. Okay, so this is a very important point because we're talking about aging, all the hallmarks of aging. So a quick run. First of all, what you see here, just I'm showing this upper graph. Those are mice that those in green got SGLT2, and you see they lived longer, okay? But it's even not as impressive in humans, because in humans, and by the way, this is studies with 4,000 people, over 32 months, not that long. And you see that metformin decreased by more than 30% kidney, cardiovascular disease, and overall mortality. Okay? We have this evidence. By the way, most of the patients had diabetes. Not anymore. Not anymore. It's used half of the time in the United States. It's not used for diabetes, but for cardiovascular and kidney disease. But it was actually, it's an anti-diabetic drug, and all of a sudden you see that it has many other effects. So let me just run through 4 examples of health span. SGLT2 in another study, 810 days, decreased cardiovascular and renal endpoint. Metformin in a patient with heart failure, 30% improvement. Biphosphonates, 33% decrease in cardiovascular disease. And semaglutide, GLP-1, have many outcomes, but also renal outcomes, just as an example. The same with mortality. SGLT2 decreased mortality by 32% with another study. Metformin, 24% of diabetes with arterial embolism in another study. ICU mortality by 59% with biphosphonate, and GLP-1 decreasing 43% of mortality. So I can go on, and we're going to publish all those studies very soon with a very strong recommendation. But those drugs have been out for years. And the important thing to know is that it's legal for doctors to repurpose those drugs. We do it all the time. For example, metformin was first used for obesity. People with metformin lose 5 to 10 pounds, but that's not exactly a treatment for obesity, but it's the first line of drugs for PCOS. It's the first drug that you would give to prevent diabetes in pre-diabetics. And as I said, in COVID, it's not the first, in New York last summer, it was the most prescribed drug when there was a little COVID epidemic. So it's legal, and why not use it for aging? I would say that we do want to be conservative. We want to think more as a secondary prevention. By the way, those treatments I wouldn't take when you're below 50, because I don't know the antagonistic pleiotropy here. Metformin decreases IGF-1, but low IGF-1 is not good in young people, okay? So you shouldn't take it unless you're diabetic. You shouldn't take it when you're young. So I think when we start using those drugs, after maximizing health, we should think of it more of as a secondary prevention. And maybe our patients should be over 60 or over 65. And then the question is, you have those 4 drugs, how do you decide what to use to each patient? And this is what we're trying to fill up, and this is just a work in progress, so don't take it literally. But for example, cardiovascular disease can be affected by any one of those drugs. So if you have a patient that already had MI, already his cholesterol is okay, you can think of any one of those. But there are some things that are specific, like COVID is better with metformin, NASH is better with GLP-1, there's renal indication, cognition rising. Now GLP-1 has so much data on cognition too. So my point is, read the coming literature, read the literature so far, and if you're a doctor, and if your patient is old for their age or young for their age, you should think of whether you can prescribe a drug that will prevent other diseases. I want to end up by several points that relate more to society maybe. So aging and the treatment of aging is not only about older adults. For example, people who recover from cancer, because we give them chemotherapy and radiation, so we age them. Okay, they need help. Children who survive cancer get heart disease at an earlier age. Many women who survive breast cancer are really older after that. People with HIV get age-related disease 10 years before their cohorts. People who are disabled, I would say poor people. Poor people in every country, at every city, live 20, 30 years less than rich people. And also, if our ambition is to go to Mars, we're not going to get to Mars before we solve this aging problem, because of cosmic radiation, we'll get cancer or heart disease on the way there, we'll never make it back. Okay, so if that's a human endeavor, start stopping aging first of all, because we'll never make it. Remember that politicians have to know about the longevity dividend. They have to understand that spending time on your health is much cheaper investment than just treating everything else. And really, each one of you can spend time more on maximizing your health and avoiding the diseases. And this is a strong message, and also a strong thanks, and I'm so grateful for you listening and for inviting me here, and I wish you age later and prosper. Thank you so much.
Thank you so much, sir. Indeed, this was an overwhelming occasion to witness this oration on a topic which is actually sounds so much unrealistic and hypothetical, but you have delivered this wonderful and informative talk full of deep insights and research-based facts. As a gesture of our gratitude for delivering this third Dr. K.D. Gupta Memorial Oration, it's time now to felicitate our orator. May I request all the dignitaries to please come to the center of stage. So can we hear a huge, huge round of applause for Dr. Nir Barzilai. So, I request first and foremost Dr. M.L. Swankar to felicitate Dr. Nir with a shawl. I request Dr. Vikas Chand Swankar to present the oration plaque. I request Dr. Achal Gulati to present the citation scroll. And I request Dr. Rajiv Gupta and Dr. Sanjeev Gupta along with Dr. Swankar to present the memento. And I request the Emeritus Chairperson also to present the honorarium, oration honorarium to Dr. Nir Barzilai.
Just I request to give a standing ovation to Professor Nir Barzilai.
May I request you, sir, to say a few words? Dr. Nir, sir. Kindly take your seats, please. Kindly take your seats. So would you like to say something after the oration, just a few words?
You know, I would have done it better before that. Now I'm crying a little bit. I'm really overwhelmed. First of all, guys, you were just a terrific audience. I mean, there's no way that I give a lecture in my institute and most people are sitting till the end. I'm very grateful to you. And really, I'm spreading, you know, it's important to spread this message around the world that aging is something we can do something about, and it's important to do it sooner rather than later. But I'm really touched by this, such a warm welcome, and I'm just overwhelmed. Thank you very much. That's a special, special day for me. Thank you.
Thank you, sir. Thank you. So, just to conclude, may I request Dr. Vikas Swankar to propose a formal vote of thanks?
This vote of thanks was supposed to be delivered by Chairperson Emeritus Dr. M.L. Swankar, but due to some unavoidable commitment, he had to leave on an urgent basis. So, words are his, I am just speaking on his behalf. Thank you, Dr. Nir Barzilai and Mrs. Laura Barzilai for coming to this momentous occasion, and thank you, Professor Nir, for delivering the third Dr. K.D. Gupta oration at Mahatma Gandhi University. We are really privileged and humbled to hear you, sir. Thanks to the Gupta family, Dr. Rajiv Gupta, Dr. Sanjeev Gupta, and other members of the family. We have had good family relations with them since I have gained memory. So it's been almost more than 40 years. and no better way of paying tribute to the elders of the family than organizing such academic literary events. Thank you, Dr. Sanjeev Gupta, Dr. Rajiv Gupta. Thank you to all the students of Dr. K.D. Gupta and the alumni of SP Medical College, Bikaner. Thank you to all the dignitaries, eminent guests, faculty members sitting in their audience for sparing time and listening patiently to this program. Thank you to all the guests watching the live telecast of this program online. This again is a message from Dr. Swankar. Professor Barzilai, we will be grateful to you if our university can collaborate with your institution in furthering the research in geroscience and anti-aging strategies. So we would be happy to take it forward from there. Bhagavad Gita is a sacred book of Hindus, and it is a guiding book of almost entire humanity. From that, I would like to quote a verse from chapter 16, shlok 17. Yuktahar viharasya, yukt chestasya karmasu, yukt swapnav bodhasya, yogo bhavati dukkhaha. Those who are moderate in eating and recreation, balanced in work, regulated in sleep, can live long, healthy, and mitigate all sorrows of life. So this was relevant on our topic. Thank you to the organizing team of the auditorium. Thank you to the university officials, the Vice Chancellor, the Chief Advisor, and other faculty members who have played an instrumental role in organizing this oration. And thank you to our Master of Ceremony, Dr. Bushra, and her team. I now invite all of you to join us for lunch after the national anthem. Thank you so much.
Thank you, sir. Kindly rise for the national anthem. Thank you. All guests and faculty members are invited for lunch at the Grand Cafeteria RK Block. Thank you.
Did you